All right, this is going to be assignment 2, case 1 for a horizontal plate put into an incoming flow. Here is my UCF ID. It is hard to see right now because my camera is not good. My UCF ID is 4065587. To begin this simulation tutorial, first I need to let you know that I have done most of this stuff ahead of time, just because it saves time in regards to like uploading it to YouTube and getting things processed. So most of the things you see here, again, have been completed, but I'm going to run through the process to show you how I actually did it. So first and foremost, we have to go through the geometry of our of what we're going to be doing here. So here I have like a sketch 1. It highlights kind of everything here. I'm going to actually zoom in really quick and show you how I created this shape here. So here, similar to assignment 1, you just basically create a rectangle, which you can do by going to sketching, and then you can go to rectangle or line. I'd prefer rectangle, it's easier. Draw a rectangle, go to dimensions, go to general. You can actually pull down. When you click and pull, you can show your dimensions for each of those. You want to make sure that your units are in centimeters for the specific project. The height is 5 centimeters. The length is 50 centimeters. That can be changed. Once that shape is made, you have to create the system, which is this large rectangle you see around it. In order to draw that rectangle, you do the same process. You go to the sketch, you go to rectangle, and you just draw it large enough so that the wake region can be noticeable when you go to do those contours at the end. Once you have your sketch done, in order to get this grayish background surface, you need to go to Concept, Surfaces from Sketches, click that. You then have to click your geometry, which you can do by doing Box Select. You can then click Generate, which generates the shape. And that is how you do the geometry of your initial setup. Moving on to the meshing portion. We'll share this screen really quick. We have, let me pull up this mesh. This is what the mesh looks like. It was done by going to here, doing an automatic method by clicking that, which does a general mesh over the entire shape. Let me use that. Let me make sure I am screen sharing still. Okay. Then after I finished that, I was able to go down to here, adjust the element size to 0.05. I went to refinement, switched it to level 2, and then I generated it. And then that was basically all I needed to do for my mesh. For the name selections, this is very important because this is required for the next step. You have to name your inlet of your system, your outlet of your system off to the right, the symmetry, which is the top and bottom. And when we zoom in, it is green right now just because I clicked something off, but it won't affect anything. The front of the plate, the back of the plate, the top of the plate, and the bottom of the plate. All these are necessary because when we tabulate our forces, those places need to be named. Next up, I'm going to go to the solution portion of this. Again, the solution has been calculated already for the most part. Just going to run through this very quickly. So for our models, we're going to use the viscous one right here, the viscous model. We're going to click K epsilon, standard, enhanced wall and treatment, and pressure gradient effects. Okay. Minimize that. Materials, we're just going to be using our air, which is our fluid. Our boundary conditions, there's only one thing that we actually have to change in here, which is our velocity inlet. And the only thing that really needs to be adjusted is our velocity, which that was set to 10 meters per second, causing a turbulent flow. Next, we have our reference values. We have to make sure we are calculating from our inlet. We go to our initialization. We click initialize. It will initialize off to the right. It usually initializes in 9 iterations. We can then go to run calculation, which will calculate our solution. Once that is complete, we can go to reports and forces to actually identify where the forces are and how they are acting on the plate. So here, this is the back of the plate. This is our pressure force, our viscous force, and the total force. And again, you have the back, bottom, front, and top of the plate. And down here, this is the net pressure force acting on the plate, this is the net viscous force, and this is just the net force total between the viscous and pressure acting on the plate. All right, so next we have to go to our workbench. Make sure I am sharing my workbench. I am, okay. So we're going to next go to our results. So that's going to start up. Give it 1 second. All right, now I'm going to share that screen promptly to make sure that we are on the same page. Perfect. Okay, so next we have this shape. We're going to go to the XY plane. We're going to first insert a velocity profile contour. Velocity profile. Okay. Down here, we're going to be calculating at symmetry 2. We're going to be calculating pressure eventually, but right now we're doing velocity. And we're going to choose this as 200 contours. We'll apply that. Wait till this loads down here. And boom, this is our velocity contour of the external flow. I'll zoom in very quickly. As you can see, we made a large enough region for our wake to be noticeable. And here is the zoomed in image right here. Next up, I need to go to, let me adjust that really quickly. We need to do a pressure contour. In order to see that, I'm actually going to unclick my velocity contour. I'm going to insert contour. This is going to be pressure. That's doing at location 2. Pressure is already checked, and we just need to switch this to 200. Make sure this is symmetry 2 still, and apply. Down here, it'll start to load. And here we go. Here is our pressure contour. Stagnation point will have the highest pressure, which can be seen just like that. So that's good. We're expecting that. Next, we need to identify where the flow separates. So in order to do that, we can uncheck that. We can go to our vector, and we're going to do flow separation. We'll go down to symmetry 2 again. And the rest is good, so we can apply that. Let's quickly zoom in on this. As you can tell here, our flow will begin to separate at approximately 35 centimeters from the front to the back. And again, that's just due to the adverse pressure gradient that happens when we have this, this wake region in the back. In order to get an exact location, it can be difficult in here, but you can actually go to your setup area again and go to your plots, XY plot, and then plot the shear stress along the top plate. And wherever the shear stress is 0 is where you begin to have that flow separation. That will conclude assignment 2, case 1. And yes, I will proceed to do the next video. Thank you for watching.